Have you ever stopped to think that you are watching this video through invisible waves traveling through the air? That your screen works by manipulating light itself? And that all of this began with a seemingly useless scientific discussion about the nature of light? This is a story about how the invisible became the foundation of our visible world. A journey that begins with a simple question, what is light, and ends with Wi-Fi, Bluetooth, and all the technology that connects us. In our last encounter, we saw Galileo challenge the world and nearly pay with his life for giving us a universe in motion. Today we will discover how brilliant minds unraveled even more mysterious forces, forces we cannot see, but that carry this video to you at this very moment. This is the story of the light from shadow. If you want to discover how humanity's greatest breakthroughs were born from seemingly useless ideas, hit subscribe now. You will not want to miss what is coming. To understand our hero genius, we must first understand the world he was born into. In the 19th century, physics still lived under Isaac Newton's colossal shadow. The universe though no longer revolving around us was still seen as a great clockwork mechanism. A cosmos of gears and parts period of colliding particles and forces acting at a distance. A model we could, in theory, dismantle and understand period piece by piece. In this scenario, light was one of the greatest enigmas. What was it after all? A shower of tiny particles, as Newton himself defended with his corpuscular theory? Or was it a wave a disturbance spreading through space like ripples on a lake? This was the theory of brilliant Dutch scientist Christian Huygens. Huygens' theory was elegant. It explained phenomena like diffraction how light bends when passing through a slit something Newton theory could not do. But it had a massive problem period, a true Achilles heel. If light is a wave, what exactly is waving? Sound waves need air to travel. Ocean waves need water. What medium did light use to travel through the absolute vacuum of space? The idea of a wave without a medium seemed as absurd as a surfer trying to catch waves in the desert. Because of this issue, and Newton's overwhelming authority, wave theory remained in shadow for over a century. The stage was set. The physics world had a central mystery and was trapped in a mechanical worldview. For the next revolution to happen, someone was needed who was not bound by these ideas. Someone who thought differently, someone from outside the system. Enter our protagonist, Michael Faraday. Born in 1791, son of a poor blacksmith, Faraday had no formal education. He became an apprentice at a bookbinding shop. But there, among leather, paper, and glue, he saw not just work, he saw opportunity. He voraciously read every book that passed through his hands, especially science books. His passion led to a stroke of luck, he landed a job as lab assistant to one of Britain's most famous chemists. But Faraday was not an ordinary scientist. His genius was not in complex equations, he barely knew them. His genius lay in his physical intuition in his ability to visualize the invisible. While other scientists saw electricity and magnetism as mysterious forces acting at a distance like Newton, gravity Faraday saw something different. In his experiments with wires, coils, and magnets, he did not see empty space between objects. He saw space filled with lines of force. For him, space was not a passive stage period. It was alive, vibrant, imbued with tension and structure that guided phenomena. It was a revolutionary shift in thinking. Even nothingness now had properties. Faraday was like an artist who saw a landscape invisible to everyone else. But lacking mathematical language, he struggled to describe his vision in terms the scientific community could accept. He was painting the image of a new reality but needed a translator. That translator came in the form of James Clerk Maxwell, a Scottish physicist and mathematician. Maxwell was Faraday opposite a mathematical genius, a master of equations, but he had the sensitivity to see the deep physical truth in Faraday intuition. If Faraday painted the picture, Maxwell wrote the score. Between 1861 and 1862, Maxwell translated Faraday lines of force and experiments into four elegant equations. These equations dash, now known as Maxwell's equations dash, are one of physics' greatest achievements. They describe how electric and magnetic fields create and interact with each other. They show how a changing magnetic field creates an electric field period, and how a changing electric field creates a magnetic field period in a self-sustaining cosmic dance. But analyzing the consequences of his own equations led Maxwell to the most shocking discovery of his life. The theory predicted this dance between fields would generate a wave propagating through space period, even in vacuum, an electromagnetic wave. And then period, the eureka moment. Maxwell calculated the speed at which this theoretical wave should travel. The result? 300,000 kilometers per second. It was precisely the speed of light dash, already measured with great accuracy at the time. The conclusion was inevitable period and spine-tingling. Light itself was an electromagnetic wave. In that instant, centuries of mystery dissipated. Light, electricity, and magnetism, dash, which seemed like such distinct phenomena, dash were actually different manifestations of the same fundamental force. Huygens question dash, what is waving? Question mark dash was finally answered. What waves are the electric and magnetic fields themselves? The bookbinder Intuition, translated by the Scottish genius mathematics, had unified a vast area of knowledge and revealed light true nature. Maxwell theory was beautiful period, but still theory. The 19th century mechanistic mentality still resisted. To save the idea that waves needed a medium, physicists invented the luminiferous ether dash, a ghostly substance, invisible, massless, but perfectly rigid, that would fill the entire universe. It was a theoretical crutch period, a final gasp of old physics. But this crutch was about to be broken. First, in 1887, the famous Michelson-Morley experiment tried to measure the ether wind caused by Earth movement. The result was one of science history. Most important failures dash, there was no ether wind. Light speed was always the same, proving it needed no medium to travel. Faraday and Maxwell electromagnetic field was real in itself. Soon after, German physicist Heinrich Hertz decided to test Maxwell's other prediction dash, the existence of other electromagnetic waves, invisible ones. In his laboratory, he built a crude device that generated a spark period and a few meters away. Another simple circuit produced a spark and response period with no wire connecting them. Hertz had created and detected the first radio waves. He demonstrated these invisible waves traveled at light speed and behaved like light dash. They could be reflected and refracted. Maxwell theory was proven. But when asked about his discovery usefulness, Hertz's response was emblematic. I see no use for this. It is just an experiment proving Professor Maxwell was right. For the pure scientist, truth beauty was the ultimate reward. But the story was not over. The final character was missing period. The man who saw not just beauty, but opportunity. Guglielmo Marconi dash, an Italian inventor dash, was not a theorist like Maxwell or a pure experimentalist like Hertz. He was an entrepreneur. He looked at Hertz's useless discovery and saw the future of global communication. He thought, what if we could use these waves to send messages across oceans without expensive submarine cables? While his father criticized him for wasting time on useless electrical experiments, Marconi persisted. In 1901, he achieved the unthinkable dash. He transmitted a radio signal dash, the letter S in Morse code dash across the Atlantic Ocean period from England to Canada. Wireless telegraphy was born. The world shrank overnight. Ships in distress could now call for help, as the Titanic would do a decade later. The uselessness of Hertz waves dash born from Faraday intuition and Maxwell's equations dash had become one of humanity's most vital technologies. And today, where is this journey legacy? Look around you. Look at your hands. Faraday, Maxwell, and Hertz discoveries are the seeds of a technological forest surrounding us. Wi-Fi and Bluetooth are nothing more than sophisticated versions of Hertz experiment. Your router and headphones are constantly performing Maxwell Miracle Dash, transforming digital data into radio waves traveling through air. Your ability to watch this video without being connected by cable is their direct legacy. Your phone and TV screens Dash and the digital cameras capturing our world Dash are direct applications of our mastery over light. They manipulate light, converting it into electrical signals and back to light Dash, transforming photons into pixels and pixels into stories. Your microwave uses part of this spectrum to heat food. Your TV remote uses infrared waves. The fiber optics giving us high-speed internet is light traveling through glass cables Dash transmitting data at the universe maximum speed. The GPS guiding our way depends on radio waves from satellites. X-rays let us see inside the human body. MRI manipulates electromagnetic fields to create detailed images of our tissues. The transition from a universe of parts and gears to a cosmos filled with invisible fields was one of humanity's greatest thought revolutions. The initial uselessness of visualizing lines of force became the foundation of our entire connected society. The screens in our hands Dash the Wi-Fi in our homes, Dash our ability to talk to someone on the other side of the planet instantly Dash. All of this is the harvest of minds that dared to see the invisible and understand it. The history of science shows us this powerful lesson Dash the most abstract and apparently useless investigations are, in the long run, the seeds of technologies defining the future. Who would have thought 4 mathematical equations, born from a self-taught man, intuition, and a Scotsman genius, could completely reorganize our reality? Next time you connect to Wi-Fi, remember you are using the legacy of minds that dared question the obvious and discover the impossible. If this journey through the invisible changed your perspective on how science shapes our world, share this video. Knowledge like light was made to propagate. And get ready, Dash, because in the next chapter, we will see how physics completely lost control of reality. The fragmented reality colon. When physics lost control, Dash an even more disturbing adventure through quantum mechanics heart, where we will discover that light itself has a dual personality. If you have made it this far, you cannot miss what is coming next. Subscribe now. Think in the void.